this time, Lord. Thank you because we have started this lesson, Father. But I need you, Lord, to provide us with ability to reason, Almighty Father. I need you, Lord, to open our inner mind so that everything what they are going to learn, we shall understand it, Almighty Father. Provide our teacher with knowledge to teach us, Almighty Father, because he cannot teach us alone by himself, but he can teach us the knowledge that comes from you, Father. I pray all this believing in the name of our Lord Jesus Christ. Amen.
Amen. Thank you so much for the word of prayer. Peace. Okay, now last time we started on our equation of a straight line, and that is the topic we are covering. So last time in our lesson, we looked at intercept. We looked at how we can obtain an intercept, and now in our lesson today, our major area of concentration is going to be on the equation of a straight line. How do we obtain an equation of a straight line? And therefore, by the end of this lesson, each one of you should be in position to find the equation of a straight line. So kindly write your heading, title, equation of a straight line, or finding the equation of a straight line. That one should be your title, and it's going to be our lesson focus for today. So you can write it somewhere in your book as we dive deep into our lesson. Okay, perfect. Now we are going to start. Now, when we are finding the equation of a straight line, there are three things that we need. But before we start, I want you people to go through the chart and tell me, for this particular graph I have displayed, what is the y-intercept? Tell me what is the point on the y-intercept. Time for check whether we still remember what we covered in our past lesson. Put in the chat, what is the y-intercept? Okay. Einstein has said 3. Good. 3, Nolan. Okay. Hanifa 3. Very good. Last time we said that our y-intercept is that point on the either y or x-axis where our line cuts it. And we said we have two intercepts. We have what we call the x-intercept and the y-intercept. For this particular line of ours, this is what we call the y-intercept. And the y-intercept always lies along the y-axis. And for this one here is what we call the x-intercept. And x-intercept always lies along the x-axis. Now, when we are looking for the equation of a straight line, an equation of a straight line is written in a standard form as y is equal to mx plus c, whereby m stands in for our gradient and c stands in for our y-intercept. Therefore, whenever we are given a graph and we are looking at the equation of a straight line, then it means that the very two things that we need the gradient and we need the y-intercept. So those are the two things we are going to find. And last time we looked at how we can find a gradient when you are given a line. And what did we say? We said that when we are to find a gradient, we have two things we can do. So the first thing I want here to do, we are going to first find the gradient. Find the gradient. And we say that when we are finding the gradient, we have two approaches. One, you can identify points along that line. Alternatively, you can draw a square, you can draw a right-angled triangle, and then from it, you can be in position to obtain. So allow me to use the right-angled triangle to be able to find my gradient. And we say that when we are using the right-angled triangle, I will draw a triangle like that. Then from here, I drew like that. That is my right-angled triangle. And I know very well that at this point here, I have 90. We say that our gradient, which is m, is always given by the rise out of the run. Now, members, through the chart, what is our rise? Put in the chat quickly. What is our rise? What is our rise? Put your answer in the chat. What is the rise? Noelin is saying 4. No, Wahala is saying 4. 4, Isaac. Okay. I think members have gotten 4. Very good. So the rise is 4. So those who did not attend, we only count the units. This is 1, 2, 3, and 4. So those are 4 units. Then, and also when you observe the scale, you will notice that it is 1 unit. Then when you look at the run, 1, 2, 3, and 4. Also, the run is 4. So I will say 4 divided by 4, which will give me my 1. Alternatively, we say that in case this approach is not friendly to you, then you can identify any 2 points along your line. And these points, I can just say, let me just choose any 2 points. Take an example. I have this coordinate here, which is 1, 4. Then I have another coordinate, maybe this coordinate here, any 2 points along your line, which is -2 and 1. So I'm going to use 1 and 4, and then I'll use -2, 1. Then after we say that as long as those coordinates you have taken are lying along the line, it is very okay. No matter which coordinates you use, you'll always obtain the answer. Then after we said label x1, y1, x2, and then y2. And therefore, we say that our gradient always is given by y2 minus y1 out of x2 minus x1. So from our points that we have chosen, we have 1 minus 4 out of -2 minus 1. So you can notice that 1 minus 4 will give us the -3. -2 minus 1 gives us the -3. And therefore, when you divide -3 by -3, you end up with your answer as 1. So our gradient is 1, and it is exactly what we obtain. Now, number 2, when it comes to our equation of a straight line, we shall need this intercept. And therefore, the intercept, according to our line, we have is that point that cuts the y-axis. And for this graph, you notice that this is the point here. So this is the point that we are going to take on. So this point at here and this point here is 3. So meaning that we shall just say here that our C is equal to 3. Therefore, we go back to our equation of a straight line, which is mx plus c. So where there is m, we put our 1. So we shall say 1x plus our intercept, which is 3. So that is our equation. But as a mathematician, at times there is no need for you to put this 1. Therefore, I can just write y is equal to x plus 3. And this is my equation for this particular line they have drawn. Members, let me know through the chat. Are we on the same page? Let me know through the chat. Are we on the same page? Okay, perfect. Okay. Let's now write. Now those who are not on the same page with us, you can raise up the hand. Given that you have not come late, given that you have been on. Teacher, I am a bit confused. I thought x is -3. What is x? No, Zara, you need now to know. Zara, you can raise up your hand. Zara, what you need to know. Zara, which -3 are you talking about?
Teacher, I'm so sorry. I've been in all your lessons, but I'm getting a bit confused. The issue is now, remember when we were doing we were finding the y-intercept or something like that, and we would do that m is, of course, m is the gradient, that's correct. But when we would say like 3x, so when we were finding for y, we would always say x is 0. Am I right? Because now I'm a bit confused when you said, now the numbers you gave us, I had calculated them, and I think the y was correct, but I think I've been getting the gradient wrong. What I would do for the gradient, I'll just write the number on the x-axis. So it's a bit different, right?
Yeah. Now, Zara,
yes.
there are 2 things. Now, the cases we are dealing with, they had given us the equation. But now the case we are having, we are not given the equation, and they want us to find that thing that you had. Are you getting the difference?
Please, I beg your pardon.
I'm saying that what we were given initially, what you are referring to, they had given us the equation of a straight line already. And when you are finding the intercept, y-intercept, we said x is equal to 0. And when you are
Yes.
finding the x-intercept, we said y is equal to 0. That's what we did.
Yes.
But for that
Yes,
case,
yes.
it is because we had the equations with us. That's why we are doing
Yes.
so. But here they have not
Oh.
given you the equation. So you have to find it.
Oh.
Hmm.
Okay, teacher, but that remember you gave us an exercise where you said find y-intercept and and m, the gradient. So for the numbers, the gradient, we simply had to do rise over run, not the equation like y is equal to this and this and this.
No, like I've said that gradient has, I gave you the two formulas. So you can either say rise out of the run, given that you have your line already. But also here I've told that alternatively, you can just choose any 2 points lying along the line and then use those points. So it is up to you which approach is easier for you.
Okay. Thank you, sir.
All right. Okay. So let me hope we are finished, right? Okay, and if I says yes, okay, we are going to do another number. Those who have not yet picked, kindly wait on for the second number. Okay, the second number we have is here. Now, I want you to know that the equation of a straight line is always given in the form of y is equal to mx plus c. And I've said that where C is the intercept, and it's called the y-intercept. And y-intercept means that point along the y-axis where that line you have drawn cuts it. So when you look at our line members, can you first tell me at what point is that line cutting the y-axis? Remember, this is the y-axis and this is the x-axis. Put your answer in the chat. At what point is that? At what point is that? Phoebe has said 1. Okay, the answers I'm saying in the chat are correct. So it is cutting it at 1. Very good. So here you will just read that out that your intercept C is 1. Now your next task is to find a gradient. Now find the gradient. So when you are finding the gradient, we say those who have been attending, we said we have more than two, we have two approaches we can use. One is you drawing a right angled triangle. And for this case, if I'm to draw my right angled triangle, allow me, I can just come here along my triangle and I draw that triangle. Say, I can decide to use, it is up to you how you want to draw it, doesn't matter. But remember, do not forget, I told you always better you trace those points that are going to be easy for you to read. So I can come and I say I'm going to draw it from here up to here, as long as it touches my line. So that is going to be my right angled triangle. Now what do I do? This is my right angled triangle. And remember that now I'm dealing with what? Remember now I'm dealing with the gradient. So I'm going to say my m is equal to the rise out of the run. So do not forget your m is your gradient. Now once you reach there, ask yourself, what is the rise? Rise means the like the vertical movement, this one, up or down is what you call the rise. So members, how many units are you noticing for the rise? How many units are you seeing for the rise? Hazara has said it is 1. Good. So our rise here, we shall say it is 1. Then how many units are you seeing for the run? How many units do we have for the run? 4. Very good, Chantal, Fauza. Yes. So we have 4 units. Now, after getting, you have got your intercept and a gradient. Just come back here in your equation, then substitute. So I'll say y is equal to mx plus c. But what is my m? My m is a quarter, so I'll say a quarter x, then plus my c, which is 1, and this is equal to y. So that is your answer. That is the equation of the straight line. However, there is something we need to ask ourselves. When you look at that gradient, there is something we have not considered. There is something missing on this gradient. One, I want you to observe, is our gradient positive, negative? Put in the chat your answer. Is our negative positive, negative? That is the second question before we conclude. Zara has said it is negative. Very good. So this gradient here, we shall come on and put a negative. Also on our final answer, we put a negative. Those who don't know why we put a negative, when you are moving, you can move down like this and then move like this. And we say that whenever you are moving downwards, that is a negative. Whenever you are moving on the positive side, that is a positive. So that's why we are carrying it as a negative quarter. Alternatively, in case you want to get the gradient, we have said that get any 2 points along the line. Take an example. I can choose this point, and maybe I also take on this point. So the points I've taken is 0, 1, and the other point I've taken is 4, 0. So you label it that this is x1, y1. This is x2, y2. Then you apply the gradient formula, y2 minus y1 out of x2 minus x1. But what is our y2 is 0 minus y1, which is 1. x2 is 4 minus 0. So 0 minus 1 gives you a negative 1 out of 4 minus 0, which is 4. So you can use any approach, but what you need to be very careful is when you are using the rise and the run, please do not forget the directions, because they are the ones that are going to support you to know whether it is negative or positive. But also we say that whenever you are coming down a hill, when you find that case when you are coming down a hill, your gradient will be a negative. Okay, members, can I know through the chat whether we have started to pick up, whether we are on the same page? Are we on the same page? Maria Shant has said yes. Zara has said yes. Okay. I'm saying yeses are coming. We are picking. Okay, that is good. Okay, I think we're on the same page. Now, the people who who are how a 4. Now, how a 4, please, we are counting from here. This is once, oh, sorry. Okay. Now, those people who don't know how we are obtaining, please, we are counting. This is 1 step, 2, 3, and 4. So when you count, this is 1, 2, 3, and 4. So those are 4 units that you have moved. That's why we have a 4 for the run. So let me hope the person who was asking has obtained it. Okay. Yes, when you finish to write, you let me know. When you finish right, you let me know, such that we can continue. Okay, finished, done, finished, okay. 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 Okay, we'll give some 2 minutes to those who are still writing to finish. Then we continue. We are good to go. Okay, another one. Now this one is for you. This one is yours. Let me ask you now to do it. We are doing this number. Okay. Okay. Hope members are doing the number. Yes, people have got the answer. Y is equal to x plus 1. Perfect. Y is equal to x plus 1. Wow, 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 that is good. Now I'm going to ask you to take a screenshot. I'm going to ask you to take a screenshot. These are the numbers you're going to try out in your free time. So you'll do them in your free time. You are doing them in your free time. Okay. Hope members have finished. Okay. I have more numbers, but here you're going to allow me to do for you one number or to show you. But maybe I may ask you to let me know when you look at I want us to do part A together, and then you let me know what you think. I want everyone, we are on part A. Sorry, we are on part A. I want people to tell me on part A. Wait, sorry. On part A here, what is the intercept? What is our y-intercept for that equation? What is the y-intercept? Put your answer in the chat. What is the y-intercept? What is the y-intercept? Thank you, Zara. At least I saw Zara's answer. Hanifa Jeremy, very good. Isaac, Haley 10. Yes, Timo, yes. So there, our intercept C is equal to 7. Members, what about the gradient? Put in the chat your answer. What is the gradient for that line? Time to think. What is the gradient for part A? Isaac has said 0. MC has said, Elena has said 0. Very good. Very good. Perfect. Now, members, what is the equation? Write for me the equation in the chat. Write for me the equation. Okay, even Grace. Write Rion. Yes, Moses. Nelson, did we say infinity? Nelson, not really. Elena said y is equal to 7. Members, Elena has given us the answer already. So you'll notice that for that particular line, we have y is equal to mx plus c. But you know that for straight lines, their gradient is 0. So you have 0 times x plus your intercept, which is 7. You end up with 0 plus 7, and you end up with 7. So meaning your y is equal to 7. So now this is your equation. So this is the equation for this line. So do not get confused when you see that the line doesn't have a gradient. So your line will be 7. And always, I want you always to know that you always look at that particular line. Are you seeing that line? If it is a straight horizontal line, always lines that run horizontally are y lines. So you look at the point it goes through, that is what determines what the line is going to look like. For part B, members, let me know through the chat, what is going to be your equation? Yes, me are looking at it now. We are using our math site. Me are looking at it. What is going to be the equation for that line? Perfect, Bridget. Thank you, Isaac. Yes, Maria, Elena. Shamia, very good. Very good, Mercy. J, yes. Diana, yeah. Okay, Timo, yes, that is very good. Now, I want us to go to part C. Now, part C, I'm going to ask you, for part C, what do you think our equation is going to be for the line? Put it in the chat. Now I want to see whether we can be able to transfer knowledge from what we have been having here to the other scenario or to the other concept. Let us now apply the concept. What do you think it's going to be the equation for that line? Moses, thank you. Moses has crossed it over. Zara, Maria, yes. Sumaya, perfect. So there, but what is the gradient for that line? Let me also ask you. What is the gradient for that line? I may be here when members are going, I've not yet seen any correct answer in the chat for the gradient for that line. Sure, I have not. Letitia, perfect. Letitia has said it all. But Letitia, can you first give us the reason why you have said so? Letitia, unmute. Yes, Letitia? Oh, okay. I'm failing to get Letitia, but surely the gradient is undefined because we say that when something is vertical, when something is vertical, you cannot obtain its gradient. You are going to end up dividing by a 0. So you'll find that the gradient for such a line is going to be undefined or infinity. Yes, Aitel. Yes, Goleti.
Well, I wanted to give the answer, but I've already said.
You first tell us. First tell us what you are going to say.
What I was going to say is that when you have a vertical line, you have, okay, as you're plotting, as you're plotting those coordinates, there is 7 and 0. There is, okay, it keeps on going 1 0 7 0, something like that. So as other coordinates continue increasing, for example, in this one, the x coordinates stay as they are, while the y coordinates remain as 0. And 0 can be recorded to as undefined.
Okay. Thank you. Then lastly, Emanuela, I don't know what you are saying.
Sir.
Yes,
Sir,
Emanuela. Yes, please.
I've not understood the reason as to why that line, okay, as to why the gradient of that line at C is undefined. I've not understood the reason.
Okay, can you read for me 2 points along this line, Emanuela? Any 2 points along this line? Coordinates along that line.
Okay. 7 2.
7 2. Another coordinate?
7 4.
Do you know how we get gradient?
Yes.
How do we get it?
Gradient is equals to
So I've
gradient is equal to x2 minus x1.
So if this is your x1, y1, this is x2, y2. Substitute for us, Emanuela. What is your y2?
Y2 is 7.
Are you sure? Y2?
Hey, Y2 is 4.
Y1?
It's 2.
X2?
7.
Minus?
Minus 7.
What is 4 minus 2?
2.
7 minus 7?
0.
So what is 2 divided by 0, Emanuela?
It's undefined.
Okay. Hope you have understood now.
Yes.
Okay.
Thank you, sir.
Okay. So members, now let's continue. I have here, I want you to just write the answers quickly. You have been given the slope and the intercept. Kindly write the equations. I can write for you 1, then you write part 2 and part 3. Sometimes our slope is the gradient. So here I expect to write 2x plus 3. So write for part 2 and part 3 as I answer some questions here. Yes, Anne, Chimbale Anne.
Teacher, I don't know if it could help in shedding more light, but I thought a way of saying why a vertical line has an undefined gradient is because a horizontal line has an equation, y is equivalent to a. And a is the point where, for example, the line crosses the y-axis. But for a vertical line, it's where it's equivalent to b, and b is a point where it crosses the x-axis.
Okay.
So for horizontal lines, they cross the y-axis ever, while it's easy for vertical lines to cross the x-axis.
Okay. 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 Thank you. So, Anne, before you go, oh, she has gone. Okay, let me hope members, you have finished. Write your answers here. Yeah, perfect. The answers I'm seeing in the chat are correct. Yes, Anne?
It's I heard you saying before I go.
Yes, tell us the answer for Roman 3. What is your answer?
My answer for Roman 3 is a fifth yx plus 7.
Eh? I beg your pardon. Y is equal to?
Y is equal to a fifth of x plus 7.
Plus 7. Then for Roman 2?
For Roman 2, negative 2x.
Y is equal to negative 2x. Okay. Okay, that is
You
correct.
add that 0, but it's still the same thing.
All right. Okay. Yes. So members, there is no need for you to add on the 0 because negative 2x plus 0, anything plus 0, you remain with that same thing. So there you can drop off the 0 and only remain with negative 2x. Okay. Thank you, everyone. Okay. I think now we are going to move on. Now we have another kind of setting where we have the intercept and we have one point along the line. So how do we obtain that equation? Now, I want to let you know that when we have one point here, they have given us our intercept C as -5, and they have given us 310 as our coordinate. Now, you know very that our equation of a line y is always given by mx plus c. So what you do, first substitute for your c. Then I'll have y is equal to mx plus -5, which you can as well write as mx minus 5. Because you know very well, your primary teachers told you and they told us during our time that when you have a plus and a minus, this one will give you a minus. So that's why I leave here a negative. Now, after that step, you are going to ask yourself, this is not yet an equation because an equation will always have y and x in it, but not any other unknown. So meaning we must remove our m. So in order for us to remove the m, we shall utilize the equation that has been given, the point that has been given to us. So we have been given point 3 and 10. So what I do, I'm going to come here where I have my point, and then I say this is x and this is y. So where there is x, put 3. Where there is y, put 10, such that you can be able to get that unknown. So I'm going to say my y is 10 is equal to m times x, which is 3 minus 5. This will equal to 10 is equal to 3m minus 5. So now I'm going to collect like terms. When I'm collecting like terms, I remove the -5, I take it the other side. So you notice that this -5 can come this side. And being that it is negative this side, when it is crossing the equal sign, it becomes a plus. So I will say plus 5, then plus the 5 the other side. So this will give me my answer as 15 is equal to 3m. And therefore here I will divide by 3, I will divide by 3. And therefore my m will equal to 5. Now after getting m, I can go back and I write my equation from here. You remember from here, from this kind of equation here, where you had m, now we shall put our 5. So we shall say y is equal to mx minus 5, but our m, we have opted it as 5x minus 5, and this is y. So that is going to be our equation. Members, may I know through the chat whether... Yes, Nelson, your answer is correct. Okay. Okay, understood. Now, in case there is something you have not picked, kindly let me know. Yes, K? Unmute.
Good afternoon, teacher.
Yes, good afternoon to you.
I'm asking now, what if you're given the x-intercept?
Oh, when you are given the x-intercept. Okay, we
Yes.
shall do a scenario of that nature. But you know what?
Okay.
That whenever you have an x-intercept, there is something you can do. What you do, you make that x-intercept a coordinate. Now, you know very well, okay, that when they say they have given you an x-intercept, maybe an x-intercept, and maybe they have given it to you as maybe 4. What you do that, you know that for x-intercept, what do you know about y? Okay.
0.
Y is 0. So you write your coordinate where there is x, you put 4, then you put what? 0. Assuming they have given you another point, which is maybe 310, then you can use these two coordinates to find the equation of the line. But that one, I'm going to look at it in the next part. But in case they give you an x-intercept, use it to generate the second point.
Okay.
Hmm. Okay. Members, have we finished? You let me know through the chat. Okay, people are done. Okay, good. We have another one. We have another one. Can I first give you an opportunity to first do it on your own? Then we shall do it together. Do this on your own, and then we shall do it together. So let's give it an opportunity. Yes, and go step by step, step by step. Yes, Shuma is asking, can you get a scenario question about gradient? And yes, Yes, I have a number of questions, scenario questions that we shall do. But the first thing I want us to first learn the basics, to first get a solid foundation. And after the foundation, we shall go on and now start doing the word problems. Yes, the moment you understand these ones, then once we reach that part when we are doing the word problems, it is going to be easy for you. Yeah, first understand how to deal with them, and then after we are going to dig deep into the scenario ones. Yeah, but I have that one is good. It will be a lesson on its own about scenarios concerning the gradient. Okay, it seems people have reached somewhere. People, so may I choose? Okay. Is it Husna? Unmute. Is it possible for you to unmute? Oh, Husna is failing to unmute. Husna, can you unmute? Or Shuma? Shuma, Husna? I don't know. They're not unmuting. Okay. Okay. What about Mercy? Mercy, can you unmute? Mercy? Mercy, I'm failing to get you. Husna, I'm failing to get you. Shuma, I'm failing. Okay. Okay, unmute. Hello? Oh, unfortunately, your background. Okay, who wants to take us through this number? You can raise up your hand. Elizabeth?
Excuse me, teacher.
Yes.
All right. So we have our X and Y.
Mhm. Okay, Tell us what to do. We first write our equation of a line.
Yes. Now we
Mhm.
are going to substitute with what we have
Okay.
as our gradient has Y, sorry,
Y.
is equal to 3.
Mhm.
Our X coordinate
Okay. Like that?
yes.
Okay.
I so we are going to look for, is it C?
Okay.
And I think we'll substitute our C with 4.
Okay. Our C is?
4.
Okay. Y, Elizabeth?
Because be, be, because we are going to we're going to find the intercept of the y-axis. That C is the intercept of the y-axis, where So where it crosses the y-axis is
Oh, Elizabeth, how are
yeah.
we going to utilize this point that has been given to us?
What? Um, M is our gradient, which we have put as which are 3, and Y is equivalent to C, which is the intercept. And so
Okay, Elizabeth, you are very close, but we cannot, you may not just conclude that Y is equal to C unless you prove it. So the reason why we have that point of 4 and 8, can we prove that what you are saying, whether it is true or not, through using that point?
yes.
Can we use it now?
So you'll say Y.
So what is your Y?
8.
Y is 8 is equal to
3.
What is our X?
We don't know.
Look at the
Oh,
point
sorry.
that has been given.
Times 4.
Plus?
C.
Okay, so this gives us 8 is equal to 3 times 4. What do you get?
12.
12 plus?
C.
Okay, can we collect like terms?
Yes. We'll subtract 12 from both sides.
Okay.
So it will be 8 minus 12 is equal to C.
It's equal to C. Brilliant.
Negative 4 is equivalent to C, which is the intercept.
Which is the intercept. Now, what is going to be our equation?
Y is equivalent to M.
Now we are substituting. Remember, you have already substituted.
Oh, okay, 3 X plus negative 4.
Okay, can you write it like now a mathematician? Y will equal to
3x minus 4.
Wow. Thank you, Elizabeth. Okay, that is good. Okay, let me hope everyone, we are on the same page. I'm seeing your answers are correct in the chat. Anyone who needs some support, I'm seeing a hand up here. Hope we are together, members. Anyone who needs some support? Yes. Okay. Yes, Melissa.
Teacher, I have a question. So when we are to draw this line, is it true that we'll find out our intercept is really negative 4?
Yes, Melissa. Do you doubt?
No, I thought that it's just a formula, but I don't know if it's really what will come out.
Oh, okay.
Maybe
Okay,
I'll test
Melissa.
it. Yes?
I think we need to test it. Let me see whether I can have a free graph here. And then, okay, we are going to test it using this graph. So Melissa, do you
Yes.
stay on? and tell us.
Yes.
Okay, Melissa, we are going to draw our simple table. And in our simple
Yes.
table, we shall have X and Y. So which values of X do you want to use?
Maybe 0, 2,
Mm-hmm.
4,
Mm-hmm.
6.
Okay, good. Melissa, can you substitute for us? 3x minus 4, substitute.
There we have 3 times 0 minus 4, which will be -4.
Okay, so here we shall put -4. Go to the next one. 3 times
2
mm-hmm.
minus 4.
Mm-hmm.
That is 6 minus 4.
Mm-hmm.
Then 2. Positive 2.
Okay, go to the next one. 3 times 4 minus 4.
4.
Mm-hmm.
12.
Mm.
8 minus 4, then it's 8.
Okay, those ones are enough, Melissa, we can plot. So the first one is 0, -4. So if
Yes.
I'll have something here, so I'll place that point here. Then 2,
Yes.
2, 2, 2, I'll place it here. Then 4 is
Yes.
somewhere here and 8. So those ones, they may not fit on our graph because it is
Yes.
a bit small. But now I can join what I have already. Those 2 points are enough to give me a picture.
Yes.
So when you look at it, our graph will be like that. I don't know whether you really see whether we have the intercept is at -4 or not.
It is.
It is. Okay. Hope now it is clear.
Yes.
Yeah. Okay. Okay. So members, I think that is okay. And very good. So I'll give you some more numbers to try. Allow me to stop this recording.